Okay, students. Now in the third part, let us continue our class. So we till now studied about the Big Bang theory and its evidence. Now, were there any other theories, alternative theories? So let us see alternative theories. Alternative theories include first steady state theory, by Hoyle. Okay. Another theory was oscillating universe theory, and another was the multiverse theory. These are the three main theories that were considered to be alternative to the Big Bang theory. There are many other theories also, but these are the few main that you should know. Steady state theory of Hoyle said that there was not just one Big Bang, but which led to creation of matter, but matter is continuously created. Continuously created, and the world, the universe is in steady state, like constant since eternity. It means till the time or permanently it is in a state of constancy. There is always matter in the universe. There is no so-called particular Big Bang that started it. It was just the constancy of matter. But this theory was rejected because there were many evidences that were contradicting this theory. Another was oscillating universe theory. Oscillating universe theory says that there are not just expansion but also contraction. Expansion and contraction both are occurring in the universe in cyclical fashion, oscillating in a cyclic manner. In a cyclical manner, there will be expansion and there will be contraction. Okay, so this is another theory. Many scientists believe in it. And another is multiverse theory, that there are not just one universe, there are other universes also, where our laws may not apply. Our physics laws may not apply. They are different universes and they are continuously being created after the Big Bang, and there are many Big Bangs that are happening due to this. Okay, though of course all these are conjectures, there are less of evidence for these theories. Now very important that the basis of space, okay, or space itself, the understanding of space is dependent on many other theories. Okay, and in these, the most important one is the theories of relativity by Albert Einstein. I said theories of relativity because there was not one theory but two theories. Okay, very important to understand that Albert Einstein was the one person, a great scientist, who changed the perception of the universe through his theories of relativity. Before Einstein, there was only Newtonian theories. Newtonian theories which were about the laws of motion, the three laws of motion that were always applied to understand the happenings in the universe. But Albert Einstein came and gave the theories of relativity. So first is spatial theory of relativity. It was given in 1905 by Albert Einstein. In the spatial theory of relativity, first we need to understand what is relativity and what is spatial about it. Okay, so let us see the key points about this particular theory. Einstein said that relativity for him was that relativity is the applicability of physical laws across the universe that was relativity for him. That physical laws, all the laws of physics will apply across the universe wherever we see them. Okay, so that was relativity for him, and this theory was applicable. See, why it was spatial? Because it was for spatial cases, and we'll talk about the theory of relativity itself, but let us see the basic condition. So what is special about this theory? Because it is applicable for high speeds and energies. Not applicable or excludes gravity. This was a condition that he put in front of us. That this theory, what he was going to tell, was he was early defining all the things about the theory. So let us see what was the theory. In his theory, he said that he gave the principle of light speed invariance. This was his first principle. He said that speed of light is constant it is constant, and it is the fastest. Okay. Reason: constancy in vacuum, because there is nothing to absorb light in vacuum, and it is the fastest okay. So it is the fastest, and it is the constant in vacuum. There is no change in the speed of light, and it is the fastest in the universe. Okay. So he also said that light is fastest because it is made up of massless particles known as photons. Before Einstein, light was considered as a wave, but Einstein said that it was made up of particles. So he also gave this view of duality about light, that it was a particle also, not just a wave, and it was massless particle and chargeless particle. It was not just massless but also chargeless. Okay, and but it has having velocity, momentum, and energy. It is having energy, it is having momentum, it is having some velocity, but it is massless and chargeless. That is why it is the fastest in the universe. And here he also defined light as well. He said that it is not just the light itself. Light is nothing but the entire electromagnetic spectrum, including gamma rays, X-rays, all of the visible and invisible rays are included as light. So you can say that principle of light speed invariance means the principle of electromagnetic spectrum speed invariance. Second principle that he gave was principle of mass energy equivalence. You must have heard the famous formula E is equal to mc square. The revolutionary formula and the most elegant explanation of mass energy equivalence. That a mass can be converted into energy and energy can be converted into mass based on this formula, which is E for energy and m for mass and c is the speed of light. That means speed of light is being squared and multiplied with the mass, leading to the energy required or energy generated from the mass. Okay, so mass is multiplied with the speed of light being squared, generating lot of energy. And if you want to convert this energy into mass, that will require division with the c square. So you can see this particular conversion principle that he gave in his theory of relativity. Another thing that he said in his theory in the theory of relativity is that he said that time is relative.